Hello dear student, welcome to second class of friction, which is part of Newton's laws of motion. In last class we'll discuss about types of friction, and I'll tell you friction is basically of only two types, my dear student, not even three types. Friction is only of two types. First type of friction is, dear student, static friction. First type of friction is static friction, and second type of friction is kinetic friction. So friction is nothing but basically of two types. First is static friction and second is kinetic friction. Static friction means the friction which takes place between the surface if the body is at rest with respect to the surface, and if the body is in motion with respect to the surface. Let's suppose there is a block. If this block is at rest with respect to this surface, then the nature of friction between this block and the surface is called static friction. And if, let's suppose, the body starts moving, let's suppose the body starts moving with acceleration a, then the friction between the surface and the body is kinetic friction, and if the acceleration is 0, then the friction between surface and body is, my dear student, static friction. In last class we'll discuss that the maximum value of static friction, the maximum value of static friction is nothing but limiting friction. So limiting friction is not another type of friction, it is basically maximum value of static friction. And I already tell you, my dear student, the value of static friction is always equals to applied force. How much force we are applying on body is basically equals to value of static friction if the body is at rest. And I'll tell you that static friction changes by own, so this is basically a self-adjusting friction. And I already tell you that the value of static friction is changes as the value of applied force is changing, hence the static friction is variable friction. So the static friction is variable friction. If applied force is 0, then the value of static friction is 0. If applied force is 1 and body is not moving, so the friction is static and its value is equals to 1. Similarly, if I am applying 2 Newton force, still the body is not moving, it means the nature of friction is static and its value is 2 Newton. Once we'll reach the maximum value, that is, if body is ready to move but not moving, then that value of applied force is equals to limiting friction, because the limiting friction is maximum value of, dear student, static friction. So static friction is limiting friction is constant friction because its value is fixed. Kinetic friction is also a constant friction because its value is also fixed, but the value of static friction is changes, hence the static friction is considered to be variable friction. These topics are discussed by us already in previous class. Now we'll make some equations related to static and kinetic friction. So my dear student, try to understand each and every topic related to friction, because friction is very important part of the chapter called Newton's laws of motion. So check it out, dear student. Let's suppose if I am applying force, applied force is equals to 0. Let's suppose this is our body. We are talking about static friction. We are talking about static friction. So check it out, dear student. Static friction means the force of friction which takes place if the body is not performing motion with respect to surface, or we can say the body is at rest with respect to the surface. So my dear student, if we have a body which is placed on a surface having mass m, then let's suppose no force is applying, that is applied force is equals to 0, so body is at rest, hence the friction between body and surface is static friction, and the value of static friction is equals to 0. So remember this thing, my dear student, the value of static friction is 0 if the applied force is 0, because static friction is that friction which takes place if the body is at rest with respect to the surface. If body is not performing motion with respect to surface, then we'll say the force, the friction between body and surface is static, and thus value of static friction is always equals to applied force. So if applied force is 0, then the value of static friction is also 0. Next point is, if we'll achieve the maximum value of static friction, that friction is called limiting friction. In that case, body is not moving, but yes, body is now ready to move. After changing the value of applied force, when you'll achieve limiting friction, after then the body starts performing motion. So remember this thing, my dear student, the maximum value of static friction lies, the maximum value of static friction is equals to limiting friction. After changing the value of applied force, the body will start moving. So we will say that now the body is moving, hence the nature of friction is now kinetic, because if body is moving, then the nature of friction takes place between the surface and body is kinetic friction. So see, my dear student, the value of static friction is greater than or equal to 0 and less than and equal to limiting friction. This inequality equation is very important, my dear student. See, if the applied force is 0, then the value of static friction is 0. So we can say if applied force is 0, then the value of static friction is 0. So static friction must lies greater than or equal to 0 but less than and equal to limiting friction, because we know that the value of limiting friction, is maximum value of static friction. So this inequality equation, my dear student, is very important. Remember this thing, the value of static friction must lies greater than or equal to 0 but less than or equal to limiting friction. Moving forward, my dear student, write down next topic, law of limiting friction. Law of limiting friction. Write down next heading, law of limiting friction. Law of limiting friction. Next topic is law of limiting friction. Law of limiting friction. In first lecture of friction, I already tell you, my dear student, that friction is basically surface force. It is applied by the surface on the body. So let's suppose we have a body whose mass is m. So vertically downward it is mg, and in upward direction the force takes place, which is normal reaction force. And I already tell you, my dear student, this normal reaction force is surface force. This force is applied by surface on this block against the counter of mg, because this block is applying force mg in this surface. So we know that every action there is equal and opposite reaction. So mg will be countered by normal force. So this normal force is applied by surface on this block, hence this normal reaction force is considered to be surface force. So see, my dear student, what law of limiting friction is. Law of limiting friction says that limiting friction is represented by, my dear student, FL. So law of limiting friction says that the limiting friction is directly proportional to normal reaction force. I'll write here, limiting friction is directly proportional to the normal reaction force. Now see, my dear student, as we know that normal reaction force is a surface force, that's why, and friction is also a surface force, so that's why we'll say both the forces are proportional to each other. Now see, as we know that in this direction motion is not possible. Neither this block moves down nor this block moves up. So in vertical direction the forces are in equilibrium. So instead of N we can write mg, because this force and this force are equal. So we can write limiting friction is proportional to, my dear student, mg. Now if you want to remove proportionality and put it equal to 0, so for removing proportionality you have to put some constant. So here, my dear student, the constant is FL is equals to mu s into mg. This mu s is coefficient of static friction, and this is basically nothing but constant, my dear student. This is constant. So the law of limiting friction says limiting friction is directly proportional to normal reaction force. See, friction is also a surface force and normal reaction is also a surface force. That's why they both are proportional. Now we know that in vertical direction two forces are there. One is normal, other is mg. In vertical direction motion is not taking place, hence the forces are equal, because this is the condition of equilibrium which we already discussed. So instead of N we can write mg, so FL is proportional to mg. Now for removing proportionality we have to introduce a constant, so FL is equals to mu s into mg. This mu s is, my dear student, proportionality of constant. This proportionality is called coefficient of static friction. So this is all about law of limiting friction. Now we know that the value of static friction is greater than or equal to 0 and less than or equal to FL. So instead of FL we can write mu s into mg. So 0 must be greater than or equal to Fs, less than or equal to Fs, and greater than or equal to mu s into mg. So this is one more example, my dear student. See, you must understand this inequality equation. What I am writing here, that static friction is 0 if the applied force is 0, but its value never greater than limiting friction, because we know that the maximum value of static friction is called limiting friction. Static, after exceeding the value of limiting friction, the body starts moving. In that case no more static friction is there. In that case body starts moving, hence the nature of friction must be kinetic. So write down next heading, law of kinetic friction. Law of kinetic friction. Write down law of kinetic friction. Remember, my dear student, kinetic friction is also a constant friction. Limiting friction is also a constant friction. But yes, static friction is variable friction, because its value changes if the value of applied force is changing. So next is law of kinetic friction. Law of kinetic friction. Now we are talking about kinetic friction. So let's suppose we have a body whose mass is m, vertically downward mg, and in upward direction normal reaction force is there. And let's suppose due to the applied force the body is accelerating. So if body is accelerating, my dear student, it means body is moving. So if body is moving, then the friction which takes place is kinetic friction. Kinetic friction. And kinetic friction is represented by Fk. Again, kinetic friction is also a surface force. Normal reaction force is also a surface force. So we can say kinetic friction is directly proportional to the normal reaction force, because both are surface force. So we can write kinetic friction is proportional to normal, and we know that in this direction motion is not possible, so N must be equal to mg under the condition of equilibrium. So we can write Fk is proportional to mg. Now if we wish to remove the proportionality and put it equal to 0, we have to introduce a constant. Here the constant is we can introduce a constant. The constant is mu k, and mu k means coefficient of kinetic friction. So we can write Fk is equals to mu k into mg, or we can say Fk is equals to mu k into n, because normal is equal to mg. So my dear student, this mu k is coefficient of kinetic friction, and this is nothing but constant. This is nothing but constant. So this is what actually law of kinetic friction is. Remember, kinetic force of friction takes place if the body is in motion. Static friction takes place if the body is at rest, and static friction is always greater than or equal to 0 and less than or equal to, my dear student, limiting friction. What is limiting friction? Limiting friction is the maximum value of static friction. Under the value of limiting friction, body is at rest. But yes, after applying more than that force, we can say that the force of friction changes by nature. If body is moving, then the force of friction which takes place is kinetic friction. Now see, my dear student, there is a result by experiment. So write down by experiment, write down by experiment, mu s is greater than or equals to mu k. This is basically relation which is given by experiment, that is coefficient of static friction, my dear student, is always greater than or equals to kinetic friction. Remember this thing, coefficient of static friction is always greater than or equal to, my dear student, we can say kinetic friction. Now I'll multiply both side by normal, multiply both side by normal reaction force. So we can say mu s into n is greater than or equal to mu k into n. So mu s into n, we know that, my dear student, mu s into n is limiting friction. I'll already discuss about this thing, that limiting friction is equals to mu s into n and kinetic friction is equals to mu k into n. So this value represents Fl and this value represents Fk. So we can say limiting friction is greater than or equals to kinetic friction. So my dear student, we have three forces of friction. One is static, other is kinetic, and maximum value is limiting. So limiting friction is greatest frictional force compared to static and kinetic. Remember this thing, limiting force of friction is maximum value of friction, because limiting force of friction is greater than or equal to which beta? Kinetic force of friction. So now we'll discuss graph of friction. So write down other heading, it is graph of friction versus applied force. Graph of friction versus applied force. Write down graph of friction versus applied force, and try to understand, my dear student, this graph is very important. Graph of friction versus applied force. Graph of friction versus applied force. Graph of friction versus applied force. Friction versus applied force. So my dear student, let's suppose the graph is like this. This is our friction axis and this is our applied force axis. Now see, if the applied force is 0, I'm writing here, if applied force is 0, then we know that body is at rest, and under rest condition the force of friction which takes place is static force of friction. its value is also equals to 0. Now if I am applying force is applied force is equals to 1 Newton and body is not moving, then what we'll say? We'll say the nature of friction is static and its value is 1 Newton. So what we'll see by changing the value of applied force, if the body is at rest with respect to surface, then the nature of friction is static and its value is changing by change in applied force. So we can make the graph like this. See my dear student, if applied force is 0, then force of friction is also 0. As we changes the value of applied force, friction is also changing. Then we'll get a maximum value of static friction. This whole line represents what, my dear student? Static friction, because we know that static friction is self-adjusting friction. It changes its value by change in applied force. Then we'll achieve maximum value of static friction. That value of static friction is called limiting friction. This is basically maximum value of static friction, which is nothing but limiting friction. And in experiment we'll see that limiting friction is less than or equal to, my dear student, greater than or equal to kinetic friction. So this is the fixed value of limiting friction. See my dear student, fixed value of limiting friction. So limiting friction is nothing but constant. So this point called limiting friction, which is maximum value of static friction. Then after achieving limiting friction, if we'll change the value of applied force, the body starts moving, because we'll achieve maximum value of static friction, which is called limiting friction. But we know that limiting friction is greater than or equal to kinetic friction. Limiting friction is constant friction and the value of kinetic friction is less than limiting friction, my dear student. Kinetic friction is also a constant friction. Its value is fixed. Its value is not changing. So it's and limiting is greater than kinetic. So graph comes down and it becomes straight line. See, this value of friction is kinetic friction, and again this is also, my dear student, constant friction. So kinetic friction. Now see, after achieving kinetic friction, the graph becomes parallel to x-axis. In x-axis we have applied force. So we'll say, if we'll change the applied force, the force of friction is not changing. Once the body is in motion, that time the nature of friction is kinetic friction. Let's check it out graph again. As I already tell you, we have two different types of friction. One is static friction and another is kinetic friction. Static friction takes place if the body is at rest. If body is not performing motion, then the nature of friction is static. And we know that if the applied force is 0, then the value of static friction is 0. If applied force is 1 Newton and body is not moving, then the nature of friction is static and its value is again 1 Newton. After achieving its maximum value, that maximum value, my dear student, is called limiting friction, which is constant. Static friction is variable friction. It changes its value by change in applied force. But once the body is ready to move, then that force is basically equals to limiting friction, which is fixed, my dear student. And we know that limiting friction is greater than equal to kinetic friction. And after achieving the value of limiting friction, if you will change the value of applied force, the body starts moving. And if body starts move, then the nature of friction, my dear student, is kinetic. And remember, kinetic friction is also a constant friction. Its value is not changing by change in applied force. So this is kinetic friction, fixed value, one fixed value. This is limiting friction, one fixed value. This is kinetic friction. Its value changes if the value of applied force is changing. I hope you all understand this graph. Remember, static friction, kinetic friction. Static friction is those friction which takes place if the body is at rest. Kinetic friction is that friction which takes place if the body is in motion. The maximum value of static friction is called limiting friction. Its value is fixed. After achieving that much value called limiting friction, if you will change the applied force, body starts moving. If body starts moving, then the nature of friction is kinetic. And I already tell you, my dear student, kinetic friction is constant friction. Limiting friction is constant friction. Its value is fixed. But static friction is variable friction because its value changes by change in applied force. If the value of applied force is 0, the value of static friction is 0. If the value of applied force is 1 Newton and if body is not moving, then the value of static friction is also 1 Newton. I hope you all understand this graph as well, my dear student. Moving forward, write down next topic, it is angle of, write down next topic, it is angle of repose. Angle of repose. Write down next topic, the topic name is angle of repose. See, my dear student, what actually angle of repose is. Angle of repose is basically that this is basically related to inclined plane. Write down the angle of repose. The angle of repose is related to, the angle of repose is related to inclined plane. The angle of repose is related to inclined plane. The angle of repose is related to inclined plane. The angle of repose is related to inclined plane. Now we are talking about angle of repose. Angle of repose. So basically angle of repose, my dear student, is related to inclined plane. I am writing here angle of repose is related to inclined plane. Angle of repose is related to inclined plane. So what actually angle of repose is, try to understand. Let's suppose we have an inclined plane. This angle of inclination is theta, and let's suppose a block is placed in this inclined plane. So my dear students, see, actually that angle of inclined plane on which the block which is placed on inclined plane remains at rest, that angle, that minimum angle is called angle of repose. I am repeating once again, we have an inclined plane. Let's suppose angle of inclination is theta, and in this inclined plane a block is placed whose mass is m. Angle of repose means that angle at which, that minimum angle of inclined plane on which this block remains at rest on this inclined plane. That angle is called angle of repose. Write down minimum angle of inclined plane, minimum angle of inclined plane on which block which is placed on inclined plane, block which is placed on inclined plane remains at rest is called angle of repose, is called angle of repose. Remember this thing, what is angle of repose? Angle of repose basically related to inclined plane. The angle of inclined plane at which, the minimum angle of inclined plane on which this block which is placed on inclined plane remains at rest, my dear student, that angle is called angle of repose. Now see, try to understand, dear student. We know that for inclined plane, this is our y-axis and this is our x-axis. As we all are aware, if body carries some mass, then it must have some weight. and if mass is m, then its weight is mg, and it always acts vertically downward. So if mass is m, then its weight is vertically downward and it is mg. Let's suppose this angle is theta, so now this angle is also becomes theta, and we know that mg is weight, weight is a force, and force is a vector quantity, and if any vector quantity makes some angle, we have to split its component. We all are aware now that any vector quantity forms two different components, rectangular components. One is cos, other is sine. Cos component always lies along that line with which the vector quantity is making angle theta. So see my dear student, this mg is making angle theta with this axis. So along this direction we can write mg cos theta, along this direction we can write mg sin theta, and in upward direction a force is called normal reaction force. Now see my dear student, this block is not capable to move in this direction, so normal is in upward side and mg is in downward side. So we can say in vertical direction motion is not possible, hence the forces are equal in magnitude, opposite in direction, which achieves condition of equilibrium. And we know that in equilibrium condition we can write opposite forces to be equal. So in this situation we can write n is equals to mg cos theta. Now see my dear student, we are talking about angle of repose, and angle of repose says that minimum angle of inclined plane due to which this block remains at rest. I am repeating once again, angle of repose means that minimum angle of inclined plane on which the block remains at rest. So if you wish to want the block remains at rest, but see my dear student, this block carry a force mg sin theta in downward direction. So if no force is present in opposite direction of mg sin theta, then this block starts moving downward. But what we want that the block remains at rest. The block remains at rest because we are discussing angle of repose, and angle of repose means that angle of inclined plane due to which, on which, or we can say on which the block remains at rest. So if you wish the block remains at rest, then there must be some force opposite to mg sin theta, otherwise due to mg sin theta the block comes down, because we know that if force is acting on body then motion takes place. But what we want the block remains at rest on this inclined plane. So we can say if block remains at rest, then there must be a force which counter this mg sin theta in opposite direction. That force is called, my dear student, static friction, because the block is at rest with respect to inclined plane, and we know that if the body is at rest with respect to the surface, then the nature of force is frictional force is static. So if you want the block remains at rest on this inclined plane, then there must be a force in this direction, and this force is basically static friction. Static friction. Remember, very important point, my dear student. You have to understand this thing, because we are talking about angle of repose, and angle of repose is minimum angle of inclined plane on which the block remains at rest. If the block is in motion, then there is no need to apply static friction. But see, angle of repose means this angle on which the block remains at rest. So if mg sin theta is acting in this direction and you want the block remains at rest, then there must be a force in opposite direction to counter this mg sin theta. So here the opposing force is friction, and its nature is static, because we know that if the body is at rest, then the nature of friction must be, my dear student, static. Now see, we want the block remains at rest, so opposite forces must be equal. So we can write friction is equals to mg sin theta, and friction must be static friction, my dear student, because this is basically at rest condition. Now moving forward, as we know, static friction is always less than or equal to limiting friction. And about limiting friction, we know that limiting friction is equals to mu s into n. So we can write static friction is less than or equal to mu s into n. This is basically another equation. Moving forward, my dear student, now I'll put the value of normal reaction force. So what we'll get? Static friction is less than or equal to mu s into the value of normal is mg cos theta. So I'll write here mg cos theta. Now see, Fs, the value of Fs is mg sin theta. So I'll write here, instead of Fs we can write mg sin theta, which is less than or equal to mu s, and mg, along with mg we can write cos theta. mg get cancelled, so sin theta is less than or equal to mu s into cos theta. Take cos theta this side, so it is sin theta upon cos theta is less than or equal to mu s, and we know that sin by cos is tan, so tan theta is less than or equal to mu s. So basically mu s is theta must be greater, less than or equal to tan inverse mu s. This is the value of angle of repose, my dear student, angle of repose. And we know that mu s is nothing but coefficient of static friction. So if the inclined plane is making angle theta less than tan inverse mu s, then the body remains at rest on this inclined plane. If this angle is greater than tan inverse mu s, then the body starts performing motion, then the body moves in downward direction. So then in that case the nature of friction be changes. So this is all about, my dear student, angle of repose. In next class we'll discuss another topic, and another topic is basically if theta is greater than tan inverse mu s. So if theta becomes greater than tan inverse mu s, then the body starts performing motion, the body comes down. In that case the nature of friction changes. If body is in motion, then we know that the nature of friction is kinetic. So remember, angle of repose is that angle of inclined plane on which the block which is placed on inclined plane remains at rest, and its value is tan inverse mu s, less than or equal to tan inverse mu s. Mu s is coefficient of static friction. So I hope you all understand. Try to understand each and every point, my dear student. Make proper notes, because friction is very important, and if you are go through all the lectures, then only you will capable to understand each and every concept, because every lecture is connected with the previous lecture. So in next class we will discuss more about friction. Till then, thank you so much, dear student. Stay connected with us, study hard, stay safe, take care. Thank you so much.